all about sequences and series. Now, here's the problem with sequences and series. It starts out really easy. It starts out, a sequence is just a sequence of numbers. It's just like 4, 6, 8, 10. But there's a lot of nuances to it. There's a lot of symbols that go along with it. There's a lot of reading sentences rather than having to do the math with it. And there's just a lot going on in there. So you need to stick with the class, and you need to not use the answer key specifically on sequences and series. Because the problem is we're going to be coming up with equations for stuff. We're going to come up with numbers, and it's very easy to look at the answer and go, oh, I could have done that. They're very easy to do it, but it takes that practice to be able to do it in your head so you can do it on your test. For that reason, I strongly encourage, I know some people like having their laptop open and just checking answers as they're doing it. I strongly suggest having your laptop closed when you're doing the homework. Open it up if you're really struggling on something, or when you're done with it and you want to check all of your answers. But if I get stuck, maybe I'll skip it and try a different one and then come back to it before I look at the answer key. Strongly recommend that in this section. All right, so let's start out with a sequence. A sequence is just an ordered list of numbers. So at its heart, it's super easy. A ordered list of numbers would be 4, 6, 8, and 10. I am going to note that dot, dot, dot means this is something called an infinite sequence. Not going to be as important now, but when we get to series, it will be important to delineate between infinite and finite. So this is an infinite sequence of numbers. And I also want to point out we have to talk about what terms. So I can point to something. I can say, find the third term, and you can go, oh, Mr. Pabian's talking about 8. If I ask for the fourth term, you can go, oh, we're talking about the number 10. We've got to understand that kind of terminology. I also want to note that a sequence oftentimes uses braces. Often uses braces. That might look something like this. I might have a sequence that's like 1, 2, 3, 4. We ended with braces. I'm also going to note that this is different than this one in the fact that there is no dot, dot, dot on it. So this would be known as a finite sequence. This is finite. It ends at 4. There's no more numbers out there. If I put braces around this one, so if I would go, you don't need to put this on there, I just want to point it out. If I had braces around it, it means no different. There's no difference between braces and no braces. They don't mean anything different. It's just sometimes it's nice to have braces so you know where to start and end. But braces mean nothing. So they'll either have them or not. Don't ask about it in the homework. I mean, obviously, if questions, ask about it. But in the homework, I might have some with braces. I might have some without. And this will be throughout the section. Know that it's just a sequence of numbers, whether it's braces or not. Now, in math, sometimes it's not convenient to write out big sentences like second term, third term, and have to talk about it in that way. So rather than having to use this symbology of third term, fourth term, we're going to have something called a sub n. A sub n at its heart is going to be your term. And this term has two parts. It's got an A part. That just means it's coming from a particular list. So A just stands for a particular list. You might have an A list, a B list, a C list. The N is actually going to be your term number. So let's look at the numbers up above. We had, what do we have? We had 4, 6, 8, 10. So let's say I write 4, 6, 8, 10 again. I'm going to use braces. 4, 6, 8, 10. Well, what does this A sub n help me do? Well, since 4 is my first term, we can, in place of 4, call that A sub 1. It comes from this particular list, and it's the first element, so it would be 4. Now, when you're labeling things like this, since this is my first term with a 1, my next one always has to be 1 bigger. So if my first list is A sub 1, my next one has to be A sub 2. So I can call this one A sub 2. Increasing that, A sub 3, and this would be A sub 4. Let's pretend for a second that I didn't start here. Let's say there's a term before it. Let's say there's a 3 right here in front of 4. It wouldn't be 3, I guess it would be 2. If we had a 2 right in front of that, that would be a sub 0. The term before it would be 1 less. If I put another term in before that one, that would be a sub negative 1. So whenever you're going right, you're going to add 1 to this number. Whenever you're going left, you're going to subtract 1. That's going to be important in a second. Now, when we list things in the real world, we're always like, this is my first thing, second thing, third thing, fourth thing. In math, we don't have to be so linear about things. Yes, we can call the first term 4, second term 6, third term 8, fourth term 10. But the number next to a can be any integer. So I'm allowed to say my first term is a sub 0. Although it looks like it's my 0th term, it's my first term. I'm just calling it a sub 0. Which would be my next term would be a sub 1, my next term would be a sub 2, my next term would be a sub 3. Stretch this to kind of the breaking point, you could make your first term a sub negative 10. It's still my first term. It's the first number I'm talking about. It just happens I'm going to call it a sub negative 10. But as soon as I pick that starting point, I know what happens afterwards. Everything after it will be 1 bigger. So if I start at a sub negative 10, my next one has to be a sub negative 9, a sub negative 8, a sub negative 7. It has to follow a pattern once I tell you what that first thing is. I will note, most of the time we'll start with a sub 1 or a sub 0. Both of these are primary starting points. This is just showing you that it could be anything. All right, now with all that going on, there's going to be times where I don't know what the first term, second term is. We're going to talk about things just like this. So let's consider the term a sub n. I have no idea where it is in the sequence. It could be this a sub negative 7. It could be this a sub 1. It could be this a sub 3. A sub n. I know it's somewhere in the list. The term right before it would be, although I don't know what number it was, I don't know where it is, I know what I can give you some information about the term before it. So if I give you a sub 2 and I ask you what's the term before it, you would say, well, that'd be a sub 1. If I gave you a sub 3 and I ask you what's the term before it, you'd say, well, that's a sub 2. The term before it's always going to be 1 less. So if I give you a sub n, and I tell you to list it as a sub something, anyone want to take a guess at what that would be? It's not super intuitive. Anyone just want to take a guess? Will?
A sub n minus 1.
It'd be a sub n minus 1. A sub n minus 1 always comes right before a sub n. Anyone want to take a stab? So the next thing is, what's 2 terms after? This is 2 terms after a sub n. So I'll be a sub something. Anyone know what that sub would be if I want 2 terms after a sub n? Yeah. N plus 2. The quicker you can understand this, the easier we're going to get to recursive sequences will be for you. And that's what we're going to get to next. That's where this is important. It's recursive formulas. There are 2 types of formulas we use in mathematics. Well, in this section, there's lots of things we use. But we're going to talk about recursive and explicit. You've been using explicit your entire life. Y equals x squared is an explicit formula. I plug in a number, I get something out. We're going to start with something you might not have seen as much, and that is recursive. A recursive formula is a sequence that is based upon the previous term. It would be like, let's say I give you this sequence. I give you 4, 6, 8, 10. What's the next number in the sequence? If I have 4, 6, 8, 10, it would be, someone said it. 12. It'd be 12. What'd you do?
Add 2.
You add 2. What if I asked for the 100th term? That's going to take a while, right? Because you have to know the term before it. Add 2, add 2, add 2, add 2. So recursive formula works bit by bit by bit. You need to know the numbers before it. You add, subtract, you do something to it. That is our recursive formula. It's not super convenient because, like I said, when I say what's the 100th term, it's all of a sudden, oh, crap. Plus 2, plus 2. You have to do things. So most of the time we're doing recursive. We're just going to do a first couple terms. So this is our first recursive equation. Your recursive equation will always tell you what your first term is. You have to know where to start. And then the next part will tell you what to do with that term. So when I say list the first 4 terms, guess what? I already gave you the first term, so you only have to list 3 of them, really. So they already gave me the first term. So we can just go ahead and list that, and we're already 1/4 of the way done. Now, if my first term is a sub 1, that means my next term needs to be a sub 2. We need to increase that n value by 1, which would be a sub 2. All right. There are 2 ways to do recursive formulas. One way is we can plug it in. We'll do it a couple times. The easiest way is to actually be able to read the sentence. So we're going to start reading this sentence in basic English. This sentence is a sub n equals n plus a sub n minus 1. That's the mathematics behind it. Now, what does that mean English-wise? Well, a sub n is basically telling you the term I want. This is the term I want. So let's compare this to the term I want, a sub 2. So the term I want is a sub n. In this case, it's a sub 2. So that means, hey, that n is being replaced with this 2. So in a sub 2, my n equals 2. That's what's being replaced. I want this a sub 2 to match this. Well, that means my n is being replaced with 2. The term I want equals my n value. Oh, cool. I got that. That's 2. That's 2. We can go ahead and plug that in. I already know what my n is. And then it says plus a sub n minus 1. Well, in English, if I want a sub n, and they give me a sub n minus 1, minus 1 tells me that's the term before. So a sub n minus 1 is term before. We're going to go the long way for the first couple, but there's a nice shortcut to this. This is 2 plus, what's the term before? Yeah. This should just be 2 plus a negative 2, right? According to the sentence, it's n, which is 2, plus the term before, which is negative 2. That's the easy way to do it. We're going to do it slightly harder. The hard way is to actually plug it in and go, oh, well, that'll be a sub, my n is 2, so we can do a 2 minus 1. That would equal 2 plus a sub 1. But that's what Will already said. He said the term before is a sub 1. So in this case, it would be 2 plus negative 2, which would equal 0. For me, this is the harder way, plugging in all your n's. Sometimes it's nice when you have a big, long equation that you have to do it in. But I like it better if I can read the sentence. The sentence says n plus the term before. So let's use that idea in the next one. So my next one is my third term. N equals 3 if we're doing the n method. But I'm going to do the slightly easier method saying, okay, my n is 3, so we're going to have 3 plus the term before it would be 0. So I would have 3 plus 0, which would equal 3. Once again, I could have plugged 3 into all these. I could have said, okay, that's a sub 3 plus a sub 3 minus 1, which would be a sub 2, which would get me back up there. All right, my fourth term, n equals 4. I'm going to do it the long way again. All right, this is the short way. This is me reading it. I'm going to do it the long way. Once again, the long way is to replace all of your n's. So that would be 4 plus a sub 4 minus 1, which would be 4 plus a sub 3. Well, a sub 3 is 3, so that would be 4 plus 3, which is going to equal 7. In fact, you can probably figure out a pattern from there. Yeah.
So the sequence doesn't have to go in like a constant order.
It does not. It doesn't have to like. So if we look at this one, I'm adding 2, adding 3, adding 4, adding 5, adding 6, adding 7. There will be some sort of pattern for the most part. Some are going to be really weird patterns where you can't really put your finger on it. That you're going to have to keep figuring it out. But there's generally like there's some kind of pattern happening in there.
Well, the answer is kind of like 4, 6, 8, 10.
Correct. Yeah, we're going to have a whole bunch of different ones. And that's going to be the trouble with this section is because we're going to have to realize what the pattern is. Today is not so bad, but later we're going to have to figure out what the pattern is, what that means, what equation I come up with. That's going to be the hard part about this section is coming up with those patterns. All right. Does this make sense, though? Let's ask questions if we got them.
Wait, so for M3 you put, so it's A3 equals 3 plus 0. Did you get the 0?
I got the 0, so I did it the shorter way. The longer way is to replace, so in this case I took 2 and replaced all my n's with 2.
Mm-hmm.
So I had 2 plus a sub 2 minus 1. I did that math, I turned on the term before, and I did this. For a sub 3, I shortcutted. I used the sentence. So the sentence says replace this n with 3. Okay, I got 3. And then it says plus a sub n minus 1. Well, this will always be the term right before it. A sub n minus 1 tells you term before. So I'm like, oh, rather than putting all that stuff in, I know we're going to do the term before, so I'm just going to put that 0 in there.
Because you already know A sub 2.
I already know that this is the term right before it.
Oh, okay.
Because if you look at this one, what replaces this a sub? It's that negative 2.
Okay, so you have to do it like sequentially. Okay.
Yeah. There's no way to skip.
Yeah.
I can't do like the a sub 10 and no up there. So what I did is basically plug everything in, get an answer, do it in my head, plug everything in.
Okay.
Either way works. I don't care. You could do either way on the test. Our next one's a little more complicated. It looks nice because they actually give us the first 2 terms. My first term is negative 1. My second term is 1. So we already have our first 2 numbers, and that is a sub 1 equals 1. A sub 2 equals 1. Oh, it's negative 1 to start off with. Negative 1. Okay, just got that from the thing. All right, I'm supposed to find the next 3, because I'm supposed to, for the first 5 terms, I already got 2 of them. Cool, I just have to find 3 of them. Well, let's read the sentence. We'll do the full workout in the first one, and then we'll try to read the sentence in the second one. So the full worked out way would be, okay, if I'm finding my third term, my third term is, I'm replacing this n with 3, so I'm going to replace all of the n's with 3. So that would be a sub 3 equals a sub 3 minus 2 plus 3 times a sub 3 minus 1. I should have wrote that smaller. I'm going to run out of space on mine, I bet. Let's write small. So 3 minus 1 is a sub 1 plus 3 times a sub 2. My a sub 1 equals a negative 1 plus 3 times my a sub 2 is a positive 1. So we'll have negative 1 plus 3 would equal 2. All right, that works out. That works out fine. Plugging in this 3 for all of my n's, that works out. I get my answer. Let's do the alternate version. The alternate version is to turn this into a sentence that I understand. In this sentence, a sub n is going to be the term I want once again. This will be the term I want. A sub n minus 2, that's 2 terms back. Minus 2 means take 2 steps back. So n minus 2 would be 2 terms prior. 2 terms before. A sub n minus 1, that's minus 1. That's going to be 1 term before. So let's use that sentence to write the equation. All right, a sub 4 equals, I want 2 terms before. What number am I putting first? If I want 2 terms before, Jacob, what's the number I'm going to put next?
1.
I'm going to put 1. 2 terms before, 1, 2 would be a sub 2, which equals 1. Then we're going to have plus 3 times 1 term before. What's 1 term before this one? What number is 1 term? Yeah.
2.
It's just going to be that 2. So that's going to be 6 plus 1, which is going to equal 7. My fifth term, once again, it says find 2 terms before. 2 terms before would be that 2. Plus 3 times 1 term before is that 7. That's 21 plus 2 equals 23. And if you think about what's the next one we would do, well, we would do 7 plus 3 times 23. Then we do 23 plus 3 times whatever number that one came out to be. So we can find this pattern and start writing things more quickly. The goal is that we can write this stuff quickly. That's why we probably want to, we could plug the ends in, but if it's a big equation, I don't want to have to do it every single time. I want to start seeing that pattern. The 2 terms before, the 1 term before, the 3 terms before. Easier if we see that pattern. All right, what questions do we have on recursive formulas? I think these are the harder ones to start off with. That's why we start with it. Yeah?
How much work would you need to show?
Not much.
Alright, just like,
Yeah.
right, okay.
Like on this one, a lot of these you can kind of do in your head.
Yeah.
But get it right, because on the test, if there's no work supporting it, and you have it wrong, I have no idea what you did. Yeah. So show as much work as you think shows that you understand what's happening. So a lot of times that just takes doing like the first step, like have this 1 plus 3 times 2 equals 7, and then we can start going on. Especially this one, because we can see the pattern.
Yeah.
If I ask for the first 10, I definitely don't need to see much work past like the first 3, because you just see that pattern and you just go with it. Okay, slightly easier, I think. Easier in the sort that we can get our first few terms a lot easier. And that is our explicit formula. Our explicit formula is not based upon anything before it. Our explicit formula is a sequence in which each term is based as a function of its n or placement in the sequence. Whew, it's a lot of words for just, this is what we've been doing. Like I gave the example, y equals x squared is an explicit formula. You plug in a number, you get a number out. It's not based upon anything else. So you'll note with explicit, you don't have any of those a sub n minus 1s. You have a strict a sub n equals n squared plus 1. So if I need to find my first term, I'm just replacing all of my n's with 1. So that would be a sub 1 equals 1 squared plus 1. 1 squared is 1 plus 1 is 2.
Wait, wouldn't you do a sub n plus 1 equals n squared plus 2?
Say that again?
Couldn't you do a plus n, or a sub n plus 1 equals, wouldn't that be your first one? Because you don't know the value of n.
We do not know the value. This is true. But if I ever ask you for the first 5 or 3 terms, we can always assume it's either a sub 1 or a sub 0.
Okay.
You could pick either one of them. So I'd have been okay if you did a sub 0. Jacob, in a lot of the problems, I'll give you something like this. I'll tell you where the n starts.
Oh, okay.
Yeah. So in this one, we don't know for a fact, but it's always good to assume I meant a sub 1
Okay.
or a sub 0. So you're 100% right, but we're going to stick with a sub 1. So maybe a better way to have written this one would be a sub n equals n squared plus 1, where n is bigger than or equal to 1. Okay, so we plug in a 1. We plug in a 2 for our next one, which will be 2 squared plus 1. 2 squared is 4, plus 1 is 5. And it just says the first 3, so we just have to get to 3. That would be 3 squared plus 1 equals 9 plus 1, which equals 10. All right, our next one is a little more descriptive. It does say we have this formula where we have to go between 1 and 4. That means we have to plug in every number between 1 and 4. It didn't say how many terms I need. It just says write all of them. So we just have to go from 1 to 4 starting out. I do want to note that, look at this negative 1 to the n minus 1. We'll talk a lot about this next Monday. It's a special thing that we use to alternate between positives and negatives. And this is because negative 1 to a power will either be negative 1 or a positive 1. It won't change our sequence at all except for alternating between positive and negative. And we should see that as we do this problem. So we're going to start with a sub 1. A sub 1 tells me I'm going to replace all my n's with 1. So we're going to have negative 1 to the 1 minus 1 times 1 plus 1. All right, that's going to give me negative 1 to the 0th power times 2. Just for a refresher of algebra, anything to the 0th power is a positive 1. Anything to the 0th power is a positive 1. So negative 1 to the 0th power is a positive 1. So this is a positive 2. All right, let's plug 2 in. 2 is going to be negative 1, 2 minus 1. And then we'll have 2 plus 1. That should come out to a negative 1 to the first. 2 plus 1 is 3. Just a reminder, negative 1 to the first is negative 1. So it's negative 1 times 3, which would be a negative 3. All right, I'm already starting to see a pattern that might be developing. I got a positive, negative. This should be positive and then negative. And in my head, I'm starting to think, okay, this is 2, 3. Maybe my next one's 4. It's always good to just start getting that pattern, because as soon as you see that pattern, we can just write down. So if I ask for the first 10, it can go a little bit easier. So in my mind, I'm thinking it's positive. Maybe it's a 4. Let's check it. So a sub 3 equals a negative 1. 3 minus 1. 3 plus 1. That would be negative 1 squared times 4. Negative 1 squared is positive. It's negative times a negative. This comes out to a positive 4. That should be enough for me to say, oh, my next term is going to be a... What's my next term without doing any work? Jacob?
Negative 2 or negative 4? Negative 4.
Nope.
Negative 2?
Nope. I'll give you a hint. 2, 3, 4.
Oh, negative 5.
It'd be negative 5. And if you do the work, you should get out a negative 5. Yeah, generally speaking, so when you have these alternating negatives, don't worry about the whole numbers, the 2, 3, 4. That's where your pattern is going to come from. The negative won't affect it because it's just going to alternate between positive and negative. So when I'm doing these, I'm just looking at these whole numbers. So for me, I just see 2, 3, 4, 5, and I just tack on those negatives afterwards. Okay, factorials. Factorials are fun. They're kind of fun when we plug them in. I really like these types of problems. They can really stick people that need to use your calculator. You do not need to use your calculator on a lot of factorial problems. All right, for starters, factorials. Factorials, all you do is you take the number that's next to the factorial, you multiply it by, well, you subtract 1. Then you multiply it by if you subtract another 1. Multiply by if you subtract another 1. Subtract another 1, subtract another 1, subtract another 1 until you get 3, 2, 1. So if I have 5 factorial, it's going to be 5 times 4 times 3 times 2 times 1. And then you're done. The big thing I do want to point out is 0 factorial equals 1. You have to know that fact. You have to know that fact because there's no way to figure it out. You can plug in your calculator. You'll have your calculator, so you can always go 0 factorial and just double check. But 0 factorial equals 1 is an important concept in the factorial section. All right, we're going to list the first 4 terms. Should be pretty easy. You'll have harder ones on the test. But as a quick reminder, if you ever see this negative 1 to some power, that just tells you it's going to alternate between positive and negative. So my answer should alternate between positive and negative, or negative first and then positive. So we should see this again, this alternating stuff, because we do have a negative 1 to an end. Let's just dive right into it. So let's find our first term, a sub 1. You have a ton of room in here, so I can just slide it over here. We're going to do a sub 1 equals, well, that's negative 1 to the first power, replacing all my n's with 1. On the bottom, I'm going to have 1 minus 1 factorial. Now, like I said, negative 1 to the first is either going to be a negative 1 or a positive 1. Well, negative 1 to the first is a negative 1. Over 1 minus 1 is 0 factorial. 0 factorial equals 1, so it's negative 1 over 1, which just equals a negative 1. Now, in my mind, what I'm starting to think about is, well, this alternates between negative and positive. My next one should come out as positive. As long as I do it correctly, it'll come out as positive. Labib. It's not a variable. It is a factorial.
Okay.
It's a factorial. It tells you that you are going to do this to it. So let's say I end up with 5 factorial. I'm going to do 5 times 4 times 3 times 2 times 1. You'll see it as we keep working down. All right, so a sub 2. A sub 2 is going to equal a negative 1 squared all over 2 minus 1 factorial. Negative 1 squared is a positive 1, so now we have our positive 1 on top. On the bottom, we're going to have 1 factorial. Well, 1 factorial also equals 1. It's just 1. Nothing multiplied by it, so that's 1 over 1, which just equals 1. Nothing interesting yet. In fact, we should probably do the fifth. Maybe we'll do the fifth term. All right, a sub 3. A sub 3 would be negative 1 cubed all over 3 minus 1 factorial. Negative 1 cubed is a negative 1. Negative to an odd exponent makes it negative. In other words, it's negative 1 times negative 1 times negative 1. 3 negatives mean it stays negative. So we have negative 1 over, now we have 2 factorial. 2 factorial, although we don't really have to do work, we can look at it as being 2 times 1. Well, that's going to equal a negative 1/2. Okay, let's go down to the fourth. Fourth is going to be negative 1 to the 4th power. We'll do 4 minus 1 factorial. Negative 1 to the 4th is a positive 1. On the bottom, we'll have 3 factorial, which will equal a 1 over 3 times 2 times 1. Well, 3 times 2 times 1 is 6. So we'll go 1 over 6. I know it says we're going to do 4. We're going to do 5 terms, so we can see the factorial in operation. Well, that will be negative 1 to the 5th. We're going to have 5 minus 1 factorial. Negative 1 to the 5th is a negative 1 over not 5 factorial, but 4 factorial. And that should equal negative 1 over 4 times 3 times 2 times 1. Well, 4 times 3, that's 12, times 2 is going to be 24. Negative 1 over 24. No, I decided to do another one. It said just list 4, but we only had one that actually had the factorial working, so I wanted to just throw one more in there. You did not have to do that, though.
When there's a factorial, it just means that, like, what is it? I'm just confused.
All a factorial says is you're going to start, so if I have 4 factorial, I'm going to start at 4, and I'm going to count down to 1.
Oh, okay.
And just put multiplication between it.
Oh.
So so at its heart, it's 4, 4 minus 1, 4 minus 2, 4 minus 3.
All right.
But with numbers, it just looks like, so if I did, we'll do an example down here with 8. That might make a little more sense. Yeah.
So, is it
Maybe it'll make a little more sense when we do just straight up factorial problems. So we're doing 8 factorial over 2 factorial times 6 factorial. Now, in your calculator, if you get too big of factorials, your calculator won't actually be able to calculate it. So if you do like 3,000 factorial, it's going to say, yeah, I can't do that. That's too big of a number for you. You have to be able to do some factorials in your head. In fact, we can do this factorial problem in our head without doing any calculator work whatsoever. At first, it doesn't look like we can because 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, I don't know about you, but yeah, I can do it by hand, but I don't feel like doing all that in my head. Let's keep working. So 2 factorial would be 2 times 1. 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. Now, why we could do this in our head is because we have a lot of repeat numbers up there that we can cancel out. In fact, I see this whole pattern, 6, 5, 4, 3, 2, 1, 6, 5, 4, 3, 2, 1, and it's all chained by multiplication. So I can go ahead and cross out that 6, 5, 4, 3, 2, 1, 6, 5, 4, 3, 2, 1. Those are all going to turn to 1. It's the same thing above and below. Now all I have to know is 8 times 7. And 8 times 7 is 56. All right, and we're dividing by 2, and we're going to get out 23. Answer is just 23. Didn't need to bring out my big calculator. I'm sorry, not 23. Let's do some math. That'd be 28. Ugh. Yuck. Maybe I didn't need a calculator. All right, we should get 28 out there. All right, I put the same thing on there again, not because I'm lazy, but because I want to show you a different way to do it without writing it all out. What I want you to realize is this 8 is eventually going to get to 6 factorial because we have 8 times 6 times 7 times 6, 5, 4, 3, 2, 1. Well, this whole thing right here, 6, 5, 4, 3, 2, 1, this whole section right here is just 6 factorial. So rather than writing out all of it, this is all you need to do by hand, is recognize that it's 8 times 7 times 6 factorial. Because 6 factorial is just 6, 5, 4, 3, 2, 1. I don't need to write it anymore. Because now when I go below, I do have my 2 times 1, but I'm going to leave that 6 factorial alone. I'm not even going to write it out. That I have this 6, 5, 4, 3, 2, 1 over this 6, 5, 4, 3, 2, 1. So at this stage, go ahead and cross that out. If you want to go even deeper, you don't have to do this part. I can do this in my head. But if you want to go a little deeper, you can also cross out some extra numbers. I'm looking at 2 times 1. Well, that just equals 2. Well, that means I can turn that 8 into a 4 because it's just 2 divided by 8. Now I just have 4 times 7, which equals 28. It makes it even that much easier to do in your head. That's the easiest way to do a factorial problem with division. Realize where it ends so you don't have to write the whole thing out. And you don't have to use a calculator. There can be questions on the test, and last year there were, that said you can't use a calculator on it, and it'll have a factorial problem that looks like you need a calculator. You need to know this skill to do that. More importantly, you need to know this skill right here to do this problem here. There's no numbers. You can't plug this in a calculator, but I'm still asking you to simplify this. So if I ask you to simplify a problem like this, you need to understand what a factorial is. Not that it's just 8, 7, 6, 5, 4, 3, 2, 1. You need to remember that it's 8 minus 1, 8 minus 2, 8 minus 3, 8 minus 4, 8 minus... You need to think about it being subtraction because we need to rewrite this n plus 1 factorial. And what we're going to rewrite it as is we're going to rewrite it as n plus 1 times 1 less. What would n plus 1 but 1 less be? Yeah, it would just be n. So I'm doing n plus 1 minus 1 is going to give me n. What would my next one be? Jacob?
N minus 1.
It'd be n minus 1. What would my next one be? Would be n minus 2. And we could keep going. I'm not going to because you get the idea. Okay, let's look at n. I'm going to start with n. What would my next term be on the bottom? I'm doing n factorial. I already got n. What would be the next thing I write next to n? N minus 1. And keeping that pattern, we do n minus 2. We could do n minus 3. I'm just going to put a dot, dot, dot. Because what I want us to notice is that there's the same pattern up here as there is down here. I got n, n minus 1, n minus 2, n minus 3, n minus 4, n minus 5, n, n minus 1, n minus 2, n minus 3, n minus 4, n minus 5. So just like we could do over here, we could do all that right there. So we can go ahead and cross all of that out, and we're just left with n plus 1. There is a slight shortcut to this. I'll put it down there. It's hard to see. But if you ever have something like n plus 1 factorial over n factorial, sometimes it's nice to realize that n plus 1 factorial is n plus 1 times n factorial. because the next term is n plus 1 times n, minus 1, minus 1, minus 1. And then the bottom is just n factorial, and you can cross those out. You do not have to do it that way. You can just write it out and figure out what crosses out. But sometimes it's nice to just realize what's happening so you can cross stuff out earlier. But definitely not mandatory.